It happened in silence. No warning, no countdown, no grand announcement echoing through the universe. Just a quiet star, burning the way it always had, until suddenly it didn't. For all of human history, we've never truly seen that moment. We've seen the aftermath, ghostly clouds drifting through space, glowing like the ashes of something once alive. We've studied those remains, tried to rewind time, tried to imagine the instant everything changed. But the truth is, we've always been too late. Until now. Earlier last year, something incredible happened. Not by accident, not by luck, but because, for the first time, we were ready. Watching, waiting. And when a distant star finally reached the end of its life, we didn't just notice it, we caught it in the act, just hours after it began to die, 23.8 million light years away. In a quiet spiral galaxy, a single point of light began to grow brighter, not slowly, not gently, but urgently, as if something inside it had snapped, as if the star itself was trying to scream across the universe before it was gone forever. Back on Earth, most of the world was asleep, but somewhere, deep in the hum of machines and the glow of monitors, an automated system noticed something was wrong. A tiny change, a flicker that didn't belong, a signal that something, somewhere, had just crossed a line it could never return from. Within minutes, that signal spread. Astronomers across the world, people who had spent their lives waiting for a moment like this, saw the alert appear. Transient, something new, something alive, or maybe something dying. They didn't know yet, but they knew one thing. Whatever it was, it had only just begun. And that changed everything. Because supernovae, they don't wait. The moment a star explodes, the truth of what happened, its shape, its structure, its story, is written into the light itself. But that truth doesn't last. Within hours, maybe days, the explosion begins to distort. It collides with dust, gas, everything around it. The original moment, the pure, untouched fingerprint of the blast, gets smeared, blurred, erased, gone forever. So if you want to understand how a star really dies, you have to catch it in the first breath of its destruction. And that's exactly what they had just found. A star, caught in the act of becoming a supernova. The discovery hit like electricity. There was no time to celebrate, no time to hesitate, because somewhere out there, that star was already tearing itself apart. Every second they waited, the clearest answer they'd ever get was slipping further away. While the night stretched on, one team refused to sleep, driven by instinct, urgency, and something deeper, something almost emotional. They began writing a request, not just any request, but an emergency plea for access to one of the most powerful telescopes on Earth. They needed it now, not tomorrow, not in a few hours, now. Because far away, in that distant galaxy, a star was collapsing in on itself with unimaginable force. Its core, once stable, had begun to fall inward at speeds that defy understanding. Gravity, once balanced, had taken over completely, and as the heart of the star gave way, everything else was following, falling, crushing, ending, and then something strange. Instead of simply disappearing into darkness, something inside fought back. A rebound, a violent push outward, a shockwave trying to escape the prison of its own collapse. For a brief, fragile moment, the star stood at a crossroads, on the edge between silence and explosion. No one knows exactly what happens in that instant. Not fully. Some stars fail, they collapse, vanish, and leave nothing behind but darkness. No light, no farewell, just gone. But others fight, and when they do, they don't go quietly. They explode, a release so powerful it can outshine entire galaxies. A final act of defiance against gravity itself. The last breath of a star that refuses to fade without being seen. And right now, that breath was happening. The request was sent. And then came the waiting. Seconds felt longer. Minutes stretched, because somewhere across the world, a decision was being made. A decision that would determine whether humanity would finally witness the truth, or miss it by just a little too much. And then, approval. Instant. No hesitation. The telescope turned, high above the Earth. Under the dark skies of Chile, one of humanity's most powerful eyes locked onto that distant galaxy, locked onto a star that, just hours ago, had still been whole. Now, it was something else. Back in the control rooms, the scientists leaned closer to their screens. No one spoke. No one moved. Because this wasn't just another observation. This was the moment. Had they made it in time? Or had the universe already moved on, leaving them once again with nothing but echoes? Then slowly, the data began to arrive, and what it showed was something no one had ever truly seen before. A star. In the exact moment of its death. Not imagined. Not reconstructed, but real. And for the first time in history, the universe was finally revealing how it all begins. At first, it didn't look like much. Just streams of numbers, faint signals, patterns hidden inside patterns. The kind of data that, to most people, would feel distant, almost meaningless. But to them, this was everything. Because buried inside that light, inside the very glow of a dying star, was a secret no one had ever been able to touch before. Not directly. Not in real time. The shape of the explosion itself, for decades, maybe longer. Scientists had been trying to answer a question that sounds simple, but isn't. When a star dies, how does it actually break apart? Does it explode evenly, like a perfect sphere expanding in all directions at once? Or does it tear itself open in a more chaotic way? Lopsided, uneven, almost imperfect. The answer matters more. than it seems. Because hidden inside that shape is the story of what really caused the explosion in the first place. And until now, we've only been guessing. All those beautiful images you've seen of supernova remnants, those glowing clouds stretching across space, they're not the explosion itself. They're what's left behind long after the moment has passed. Chabchao, the time we see them, they've already been distorted, stretched, reshaped by everything around them. It's like trying to understand a firework by studying the smoke hours later. But this time, it was different. This time, they had the firework itself. The telescope didn't just collect light. It dissected it, split it apart, examined how it moved, how it behaved, how it vibrated as it traveled across millions of light years to reach us. Because light carries memory, and if you know how to read it, it can tell you exactly what it's been through. There's a strange property of light, one we barely notice in everyday life. Normally, it spreads out in all directions, its waves moving freely, almost randomly. But under certain conditions, something changes. The light becomes organized, aligned, as if it's been filtered through something, shaped by something, and that something can reveal the structure of whatever created it. If an explosion is perfectly round, perfectly even, the light it produces stays random. There's no preferred direction, no hidden pattern. But if the explosion is uneven, if it stretches more in one direction than another, then the light begins to carry that signature. It becomes slightly ordered, slightly aligned, subtle, but measurable. That's what they were looking for. Not just brightness, not just energy, but direction. The telescope's instrument was designed for exactly this purpose. It could take that incoming light and piece by piece rotate it, separate it, compare it, like turning a key over and over in a lock, trying to feel where it fits. Every tiny shift mattered. Every fraction of a difference told a story. Back in the control room, as the data continued to stream in, the tension grew heavier. Because this wasn't just another observation. This was the test. The moment where decades of theories would either hold or fall apart. For years, two ideas had stood at the center of everything. The first, imagine chaos. In this version, the explosion is messy, uneven, almost violent in its unpredictability. Energy builds up deep inside the collapsing star, rising and falling like boiling water, pushing in different directions at once. If this idea is right, then the explosion should look irregular, asymmetrical, like something struggling to find its way out. The second idea was very different. It imagined order. Instead of chaos, it suggested that the star focuses its energy along a single direction, like a powerful beam punching through from the inside. In this case, the explosion wouldn't be random at all. It would stretch outward along an axis, forming something more structured, more controlled. Two completely different visions, two completely different endings, and now, finally, They had a way to choose between them. As the results began to take shape, something unexpected started to emerge. Not chaos, not randomness, but something aligned. There was a pattern in the light, a direction, a quiet but undeniable signal that the explosion wasn't spreading equally in all directions. It had a shape, a clear one. Imagine something stretched, longer in one direction than the other. Not a perfect sphere, but something more like an oval or even a football, expanding outward through space. That's what they were seeing, a star that didn't just explode, but pushed itself apart along a single, defined axis. For a moment, it felt like the answer had finally arrived. After all these years, after all the guesses and simulations and debates, it seemed like the universe had finally made its choice. Order over chaos, structure over randomness. But the feeling didn't last, because the more they looked, the more complicated it became. This shape, this beautiful stretched-out explosion, it didn't fully match what they expected. Not perfectly, not cleanly. It was close, but not exact. And that's when the realization began to sink in. Maybe the universe wasn't choosing one idea over the other. Maybe it was doing something else entirely, something in between, something we hadn't fully understood yet. Because if the explosion were truly clean and focused, it would look simpler, more stable, more predictable. But this felt different. It had structure, but it also hinted at instability, as if whatever was driving the explosion wasn't steady, but shifting, moving, changing in real time, like something trying to push outward, but struggling to stay on course. And suddenly, the mystery wasn't solved. It was deeper than ever, because now, instead of asking which theory was right, they had to ask a much harder question. What if both were wrong, or worse? What if we've been missing the real answer all along? The data kept coming. The shape became clearer, and with it, a new possibility began to form, one that no one had fully proven before. A possibility that suggested the explosion wasn't calm and wasn't chaotic either, but something far more unstable, something alive with motion, something that didn't just happen, but fought to happen. The more they studied it, the less it felt like a simple explosion. It wasn't clean, it wasn't calm, and it definitely wasn't random. It was struggling. That was the strange part. Because the shape they were seeing, this stretched, almost symmetrical form, should have pointed to something controlled, something steady. But hidden inside that structure were subtle signs of instability, like a pattern that couldn't quite hold itself together, like something powerful, trying to break free, but unable to do it cleanly. And that's when a new idea began to take shape. What if the explosion wasn't driven by something stable at all? What if, instead, it was being powered by something unstable, something constantly shifting. Imagine trying to drill a straight line through something solid, but your hands won't stop shaking. The force is there, the direction is there, but the path keeps wobbling. Now imagine that happening inside a dying star, deep within its collapsing core. Something begins to form. A focused release of energy, trying to punch its way outward. But instead of staying locked in place, it wavers, it jitters, it twists ever so slightly as it pushes forward. And because it can't stay steady, it can't escape cleanly. So instead, it starts dumping its energy into everything around it, not far from the center, not out at the surface, but right there. Deep inside, that energy builds, pressure rises, heat spreads, and slowly, something changes. Instead of a narrow path breaking through, the entire inner region begins to swell, expanding, pressurizing, pushing outward from within, like a breath that's been held too long. And then, release. Not a neat burst, not a single clean punch through the surface, but a full, violent expansion. An explosion born not from stability, but from instability. Suddenly, everything made a little more sense. The shape they observed, this stretched, symmetrical form, wasn't the result of a perfectly controlled process. It was the aftermath of something chaotic that, somehow, still managed to organize itself just enough to leave a pattern behind, a kind of hidden order, emerging from disorder. And that realization changed everything, because for so long we've been trying to force the universe into simple categories, either this or that, either chaos or control. But this star, this moment, was showing something different. That the truth might live somewhere in between. That the most powerful events in the universe aren't always clean or predictable. But they're not completely random, either. They're messy, complicated, alive with motion, and somehow, they still leave behind something we can understand. As the data settled and the analysis deepened, one thing became clear. This wasn't the final answer, not even close. If anything, it was the beginning of a new set of questions. Because this was just one star, one moment, one explosion, caught by chance, or maybe by preparation, at exactly the right time. Out there, across the universe, stars are dying all the time. Some may explode like this, others may not. Some may collapse into silence, leaving no light behind at all. And we still don't know why. We still don't know what decides their fate. But now, for the first time, we have a way to find out, because what happened here wasn't just luck. It was proof. Proof that if we watch carefully enough, if we look often enough, the universe will show us its secrets in real time. No more guessing from the aftermath. No more piecing together echoes. Now, we can be there. At the exact moment a star takes its final breath, and that changes the future of everything. New eyes are opening across the earth. telescopes scanning the sky again and again, faster than ever before. Systems designed not just to observe, but to catch change as it happens. To notice when something appears that wasn't there the night before. To act immediately. To follow the light before it fades, before it distorts, before the truth is lost again. Because now we know how quickly that window closes, and we're ready for it. Somewhere, right now, another star is nearing that same edge, burning through its last moments, holding itself together just a little longer. No one knows exactly when it will go. No one can predict the second it will finally give in. But when it does, we might be watching, and maybe next time, the picture will be clearer, or maybe it will be even stranger, because that's the thing about the universe. Every answer it gives opens the door to something deeper, something we didn't expect, something we didn't even know we should be asking. And maybe that's what makes moments like this so powerful. Not just because we finally saw a star explode, but because, for a brief moment, we stood at the edge of something vast and unknowable, and the universe let us see a little bit further than before, just enough to remind us we're still at the beginning of the story.